All right, so this is the question 3 from the video quiz on proportions or one sample proportions. So 2 months before the election and the campaign for governor, polling indicated that 40% of the population favored the new candidate. So it looks like we're going to have a new governor because 45% favor the new governor, the new candidate over the incumbent. However, the new candidate made several unfortunate remarks 3 weeks prior to the election. 1 week prior to the election, a random sample, that's nice, of 630 potential voters showed that 317 favored the new candidate. Okay? Does the data support the conclusion that there was a decrease in voter support for the new candidate after the unfortunate remarks were made at the 1% significance level? Give the appropriate statistical evidence to support your answer. So the very first thing we need to know is we need to write our null and alternative statement. Well, this is what the status quo had been. They had 54%. And I know some of you go, well, how do I know it's not the other value? Well, the other value came from the sample. So p hat will be x over n, which in this case is going to be 317 over 630. And what I'm about to say is, I can't tell you how important it is. All right. P hat is from the sample. We never use p hat values over here. All right. We will never use p hat values over there. So even though we know that 317 divided by 630, we get this value of 0.5031. We get a p hat of 0.5031. We can never use p hat values over here. This must be a p. If this had been a mean, we would use a mu, and x bar would be our sample. This is from the sample. This is what we believe. Never use your sample values here. So never use sample values, right? You should make a note to yourself so you write it down once and won't forget it. Never use the sample values for HO and HA. Just say no, all right? So the next thing we need to do is define the parameter. So P, once again, P, not P hat. So this is always going to be P, the true population proportion of voters supporting a candidate 1 week before the election, all right? Not 3 weeks before, but we're only interested in 1 week at this point. We know at 3 weeks it was 54%, but what is it at 1 week? Conditions, they told us it was a random sample and that was given, that was good of them. We need to check the 10% population, and 630 divided by 0.1 is 6,300. Even in the small state, I'm sure that it's reasonable to assume that there's more than 6,300 voters. That'd be true for Wyoming, our least populous state. So you go ahead and note that Wyoming is our least populous state. Number 3, we had 317 in favor because NP is going to be favor, and that's greater than 10. That's good because we're checking out our normality. And NQ is 630 minus 317, and we have 313 who were opposed to the new candidate. So these are the ones in favor, and these are the ones opposed. They're voting for the incumbent. But because both of those are greater than 10, the sample is large enough to use the normal approximation of the binomial. And as we said earlier, we have 317 over 630. Please make sure X and N always must be whole numbers. X and N must always be whole numbers. All right, we go ahead and write our equation. And I want to compare equations. First, I'm going to start off with the confidence interval. Our confidence interval equation is P hat plus or minus Z star, P hat, Q hat, N. Now we're going to do our, for hypothesis testing, Z equals P hat minus P naught over P naught Q naught over N. Now, technically, you don't have to use the knots, okay? So that's fine if you don't use those. But this has to be a P hat. But this down here is not a P hat, but it is over here. So make sure that you're using P hat and Q hat for your confidence interval standard deviation, but that you're using P and Q for your hypothesis test standard deviation. All right. So you use P and Q for hypothesis, P hat and Q hat for confidence level. Be careful, don't make that error. So I'm going to go ahead and plug in, and I have 0.5031 minus the claim. This is what we are. This was our null of 0.54. And then so 0.54 ended up being right there. That was our P naught that I said used. 1 minus 0.54 is 46. Our sample was size 630. All right. So I want to know the probability. And they said they want to know whether or not there was a decrease. All right. So we're looking for a decrease. So really, I probably should have written the probability that Z is less than 0.5031 minus 0.54 all over 0.54 times 0.46 over the 630. Because this was what my alternatives, that was assigned for my alternative. So when I want to go ahead and calculate this thing, stat, arrow over the word test, and I'm going to scroll down to one proportion Z test, which happens to be number 5. My claim, or my P naught, was 54%, so 0.54. My X value, in this case, we had 317 people in favor of him and 630 not. And we want to know whether or not there was a decrease, so make sure we have that one highlighted. And I end up getting a 0.0318 with a Z of negative 1.854. So the probability that Z is less than that is negative 1.854, which is 0.0318. So our p-value, it's less than our alpha of 0.05. Because it's less, we're going to reject the null. Well, the null was that it equaled 54%. So our p-value is 0.0318. We reject the null. There is sufficient evidence that alpha equal 0.05 to suggest that the true population support for the candidate 1 week to the election is less than 54%. Simplified, all right? And I really want you to get used to writing this down. The new candidate has lost support since making the unfortunate comments. Less than 54% now support him or her. But since it was stupid comments, I'm sure it was him. Okay. All right. Continuing on. We have a second half of this problem. Concerned about the candidate's polls, the supporters have asked you to create a 97% confidence interval for the percentage of people likely to support the new candidate. Discuss whether or not the new candidate will win the election. Here, I just copied over my conditions, etc., and you can just say C part A. It's all right to say C part A because we've already done this. Okay, but what we haven't done is the actual confidence interval. So what we write is our interval, P hat plus or minus Z star. And we already, here's my P hat computation because we have X over N. And then I'm going to plug in to my equation and I have 0.5031 and 1 minus 0.5031, because that's Q, over the 630. Now, please notice I'm using p hat values here. Confidence intervals use p hat, hypothesis tests use p naught, and I need to go ahead and calculate my z star. And we're trying to do a 97% confidence interval. So second vars, inverse norm, parenthesis 1 minus 0.97, close parenthesis, divided by 2, mean is 0, standard deviation 1, because we're working with a z, and we end up getting 2.17 as our z star. Then I go ahead and calculate this, and I'm going to go stat test, and we're going to do a 1 proportion z interval. So I'm going to have to scroll way down to letter A, 1 proportion z interval, and my sample was 317. X always has to be a whole number, n has to be a whole number. If it's not, you need to round. And we're going to make this a 0.97 or 97% and calculate. So now I have 0.45995 and 0.5464. So when we look at this, we are 97% confident the true population proportion of voters who support the new candidate lies within this interval. Because 50% lies within the interval, we cannot determine with 97% confidence whether the new candidate will win or lose the election. Based on the interval, he may have as high as, this is a typo, of course, I'm famous for these, as high as 54.64% or as low as 45.995%. So from about 46% to 54.6%. Now, what is interesting is when I look at this, 54% lies within the interval. So 0.54 is still plausible. So it's possible based on this interval that they have not lost support. So we couldn't say that they've necessarily lost support, but they didn't ask me that. It said discuss whether or not the new candidate will win the election. Well, they still may have 54% of the vote, but we can't say that they'll win the election because we go all the way down to 40, we go to 46%, and 50% is in there. And if you have less than 50%, you don't win the election. So it's possible they'll have less than 50%, which means they lose. Possible they have more than 50%, in which case they win. Almost evenly split. Finally, it says, what's the smallest sample size that can be used to guarantee the margin of error will be less than or equal to 3%? So once again, I write down my formula as we did in a previous video, and we went p hat plus or minus z star, p hat, q hat over n. And please remember this part right here equals our margin of error. So if I start plugging into that, I'm going to have, actually, I'm just going to, well, if I just start plugging into that, p star, ME, our margin of error, is 0.03. And we know we have a p hat in this case. All right. What was our p hat? Well, we calculated 0.5031. And you're like, well, why didn't you use 50%? Well, we already have an estimate for the people who will support them. We use 50% when we don't. So 0.5031 times 1 minus that. So let's real quickly do, and if you're curious about where that 0.5031 came from, once again, that was my p hat value, which was 317 supporting, divided by the 630 who did not. So 0.5031, all right. And then 1 minus that, did not support him. So this is the part that did not support him, all right. And we need to calculate we wanted to calculate our z star at this point. and we wanted to, and so we're going to use a 97% confidence interval. It didn't ask us to do that, but that's what I used. So I just pulled this from above. So we needed to know that our confidence level was 97%. So we're just going to act like it was, even though it was left off. So once again, to do that, we're going to go second vars. Inverse norm. And parenthesis 1 minus 0.97, close parenthesis, divided by 2, mean a 0 standard deviation 1. And once again, I left off the 97%, but it should have been 97%, so it gives us a z star of 2.17. I'm going to divide both sides by this. And by the way, when I multiply those two numbers, well, here, let's do this so I can show you where I got the 20, because that's almost 25%. So 0.5031 times parenthesis 1 minus 0.5031, close parenthesis, is 0.24999,039. And I just wrote everything down. I probably don't need to be that precise, but that's what I used. So I came back and I divided both sides by I divided this by 217. So this goes away. Square it. When I square everything, when I take this part right here and I square it, I end up getting this part squared divided by this. And I end up getting a sample of 1,308.98. Please note, we always have to round. So we need about 1,308 voters. So that would be our answer. Please remember, n must be a whole number, so we always need to round. And in this case, we always round up. So we're always going to round up. And what this would give me is whatever my p hat plus or minus 3. This would give me p hat plus or minus 3, because that's my margin of error. All right. So this is my center. That's my estimate. So this would give me a p hat of plus or minus 3. All right. Thank you.